Hello, Adab. This is my CSC 437 Data Science course final project. The topic is Corneal ulcer detection using neural network algorithm of deep learning. So, neural network is image classification process algorithm based on deep learning algorithms. Um, so I am going to use sequential model for running this code. So this is my project proposal. Uh, this is my code, and uh, this is my data set. So first of all, I'm going to explain my data set. So in my data set, there is train folder and test folder and level CSV file. So first of all, in level CSV, there is the image names column, category, type, and grade. In category, there is three types. The three types of category. These are 0, 1, and 2. And in type 4 there are four types, 0, 1, 2, 3, 4. And in grade there is 0, 1, 2, 3. So these all are the types. The images in total are in total 712. So let's go to watch the images. This is my train folder. In train folder there is three folders based on category. In zero folder there is images. So the images look like this normally. These are all eye corneal ulcer diseases image. And this is categorical 1. This is categorical 2. After that, in my test folder there is all same 0, 1, 2 folders, and in each folder there is 66 images of eye. So let's go to the code. So in my code, first of all, I import shuttle and globe library function. After that, I call the TensorFlow library function. The TensorFlow version is 2.112 version. And from TensorFlow, I import sequential, dense, conv, 2D, flatter, dropout, max pooling, image data generator. These all will be needed in my model train. So after that, I uh, import PIO for plot graph. Then I import this uh, Google Drive link library functions to mount to the Google Drive. First, so here I have to unmount to the Google Drive and then run the code. After that, it will connect with my Google Drive account, and it will get the access of all files from Google Drive. And then I run this code, and then it will get all the access. And this part, I initialize my dataset's name. The dataset name is iDisease Deep Learning Dataset, and I call them, initialize them. It as a result, it get the path of this zip file. After that, I unzip this. When I unzip this, I got these things what I show you before. For example, look at that. It shows the image. This is how I get the access, the drive link, and drive files to my code. After that, I initialize the path of the dataset, or after print that path, I found uh, the test train and level file, and then for my code run I need a training direction, test direction. So I initialize this in here. And before I told you that in my train folder there is 012 folder. in test folder there is 01 to folder. So that's why uh, I so I did one thing, that is uh, initialize the all this direction in each single folder, each single variable. After that I print that length. So in train folder there is 35012. In test folder there is three folder, that's why 3 file, that is the length of 3. And then in each folder of 012 of train folder there is 170 images. In test there is 66 images. After that I uh, initialize the image height, image width, and guest size. And for my sequential model, I have to rescale the images from 0 to 1. So for that reason, I call the image data generator function and rescale that. So this is actually a mm, method calling variable. So when I call image generator, it actually call this method and do the recycle. So in that part, training data generator, image generator dot flow from directory. So directory is train directory, shuffle through target in my file size. This is image height, this is image width, and my class mode will be categorical. Or usually the class mode always is sparse, categorical, input, non, or binary. So when I call this variable with this method, it find the images and classes of that directory, uh, and rescale these things. Same goes to test part. So in train part I've got 512 images, and in test part I got 200 images. So in total actually that is 712 images. So now it's time to print the images. So for that I call sample training images of training uh, data generator. After that I plot it in my graph, and I saw these images. So in plot images there is figure, axis, plot, subplots, 1 2 3, axis, image, x, zip files, uh, in zip file, because there is in zip, and there is image arrays. uh, in image arrays, these the image are stored there, access stored there, and then it plot on the graph. So I print just first three images. That's why uh, these three images are shown randomly. So that is what. If I wrote the five, then it shows five images. So uh, like doing this, I also print the test images. So these are the test images. After that I uh, write the model code. So this is a model code, this is sequential model code. In sequential model code there is max pooling layer, con v2d, relu. uh, in theory part, that in sequential model I need to relu max pooling, then convert to the 2D, the dropout. So for doing this I have to write this part, and as a result the model part is ready. After that I have to model compile. So I call the compile, optimize Adam, loss, categorical, cost entropy, matrix accuracy, and then model summary. I did the model summary. In model summary, that is output none, the image size, and the image height, image weight, and the 16 is uh, the 16 is a base batch size uh, for the quantity for 32, 64, 128. These all are the actually the pixel values. And after that, I found out the total parameter, trainable parameter, non-trainable parameter, and then I initialize the batch size and epoch size. And after that, I uh, convert the each folder's images in length of images in each variable, and then I sum up with uh, sum all of this and in stored in total train value, total test value. So in total, total train value is 512 and interest images is 200, and then I finally run the model code. So for run the model, I have to call the fit function. So model.fit function, and these are the training generator steps per epoch, train divided by 16. This is my batch size. This epochs 20, validation data, validation steps, callbacks. After doing that, it will run the code, and then I have to save the path. Uh, I have to initialize the path in the save path. Then I have created a eyes that this is deep learning .h5 format file and save it there, and uh, with save weights, and then I create a JSON file. For that, I do this thing. After that, with open save path, I also save a JSON file on the same path. After that, JSON file is closed from this from the escape image transform import research. Um, the image is plot. I'm read my image resize that is there, and after that I print out the image. So I call the image, for example, content by disease uh, train 0 and 1.jpg. I call this image actually. If you see that, then look at that same image. Uh, and then resize the image to fit model. Model image size is 32 into 32 into 3. So image resize is equal to image the value. Okay. So after that, image plot, I plot it in the graph, and and then I have to find out the probabilities. The probability is equal to model predict uh, NP array, numpy array, image resize. So when I initially put the image file in the numpy array, it predicts, and it finds that yes, that is correct. And then I compared this image with other all images. So for that, first of all initialize based on the folder names, and then uh, I print the first most likely class, number of index 0, index 1, index 2, then find the probabilities, probability 0, index 1, 2, 3. So as a result, we find that the match is 0.3517. So this is how I have done my corneal ulcer disease classify using CNN of sequential model of deep learning. Thank you.